Hi guys, welcome back to Code with Dave Shook, and in today's video I am going to train a multi-layer perceptron classification model using the Apple Quality Dataset. So the goal for this project, so the goal is to like predict a good apple, if an apple is good or if it's bad, based on like the features such as size, weight, and etc. So first I imported my libraries, and then I loaded the data set using Panda, and then like I clean the data by removing missing values, dropping the ID column, and because it doesn't really help the model learn. And then after that I separate the data set into features and in the target column. So yeah, the features are like, the features are let me show you guys what the features are, which we've seen it before. These are the features, which are the apples the apples measurement, and the target is the quantity, the labels, which is right here. So these are the answers. Okay, so with that being said, let's go back to the code. So loaded the data, removed, separated the features in the target, and then so after that I imported the quantity labels because they're in text, and so I imported it into numerical values, because machine learning models work better with like numerical values, and so we had to incorporate that, and then I split the data into training and testing. As we've seen previously, the training set teaches the model, while the testing set checks for how well the model performed. And then like before training the data, I've used standard scaler to scale the feature values, and as we know, this is very important. For especially for neural network, because large differences in numbers can make it hard for the model to learn. And then now we're going to train the model, and the model that we're training today is the MLP classifier, which stands for Multilayer Perceptron. It's a type of neural network. It's a type of neural network model that learns patterns by like passing information through layers of neurons. And I have used two hidden layers with 64 and 32 neurons, as we can see. Neurons, as we can see right here. And after that I made prediction on the testing data. So yeah. So, and then we evaluated the model using accuracy, recall, F1 score, and precision, and confusion matrix, and to help us better understand how well the model classified good and bad apples. So with that being said, I'm going to run the code. Okay, so as we can see here, this is our first. Okay, let me get that out of the way first. So this is our first five. These are our first 5 rows, and then we can see that so that tells us that that tests that our data set has loaded successfully. And then we have about this is how much rows we have, which are apples, and then columns, and then these are the data types. And yeah, and then so we can see that the as we can see that the ID has been removed, and we are like only left with 7 filters, which are these right here. 7 features, which, like, these right here, and we're going to use and these are used to predict whether an apple is good or bad. So, and then now let's look at the training accuracy, which is about 99.7%. The model was able to learn the patterns of the training data, which is really good, that's good. That's a really high percentage. And then for the testing accuracy, we can see it's about 73%, which actually that's really good and very important, because the model is making prediction on data that it has not seen before, and that's good. So now let's look at the classification report. So for the precisions, we can see that the model was 94% correct when predicting bad apples, and 92% correct when predicting good apples. Now let's look at the recall. So out of all the apples that were actually bad, the model found about 91% of the bad apples, and then about 95% of the good apples. And then if we look at the F1 score, so both good and bad apples have has an F1 score of 93%, which that's really good. And then if we look at the support, this tells us how many testing examples belong to each class, and about 399 bad apples. There are about this is how much bad apples are there, and 401 good apples are there. So yeah, so the overall testing accuracy is 93%, which that's really good. Okay, so now let's look at the okay, let's bring this up. So as we can see here, the model did pretty good on predicting bad apples. That's good. This is how much it missed. Good apples, that's good. That's how much it missed. Okay, so with that being said, let's look at the other one. Okay, so this graph shows the neural network learning over time. So yeah, as we can see here, the training continues, and the model becomes more accurate over time, which that's really good. So yeah, with that being said, that's all that I have for this video. Thank you so much for watching. See you guys next time. Thank you. Bye.